Good morning, everyone. Mr. Cortina here. Today is Monday, March 30th, and today's math lesson is on improper fractions. Some materials you're going to need today are a pencil and a notebook or a piece of paper. And just as a reminder, for any of these online video sessions, feel free to pause the video or go back and re-watch the video at any time in case you missed something or you want to review or listen to something again. Okay. Also, as a piece of advice, as we're going through the presentation, look for these symbols in the bottom right corner of your screen. When you see this set of eyes, students should only be watching and listening. When you see the piece of paper with the pencil, students are or should be taking notes along with me. And again, if I'm taking notes and it's going a little too fast, just pause the video and then continue writing and taking notes with me. When you see this little guy down here, students should be working on their own. So when I give you a problem to do on your own, you should pause the video, do the work, and then press play on the video and check your work with mine on the screen. So for example, we have the eyes down here. You should just be watching and listening. You're going to repeat after me. I can identify an improper fraction and turn it into a mixed number. Okay, so far we've dealt a lot with proper fractions. You may have been introduced to this word improper fraction a little bit, and we're also going to talk about what a mixed number is today. Okay, so we're going to get to what those words mean in just a second, but today all we're going to be doing is identifying improper fractions and turning them into mixed numbers. So let's talk about an improper fraction. Well, you guys all know what a proper fraction is. A proper fraction is a number that is less than 1 or any whole number. So some examples of proper fractions that we've seen are 1/2. 3/4 is a pretty common one we've seen a lot. 2/10. Okay, so a proper fraction is just a fraction where it's not equal to a whole number. And we know it's a proper fraction because the number on top is smaller than the number on the bottom. Remember that the top number is called the numerator, the bottom number is called the denominator. The denominator represents the whole total, and the numerator represents a part of that total. Okay, so as long as the number on top is smaller than the one on the bottom, you have a proper fraction. Today what we're going to be dealing with is improper fractions. Okay, so what is an improper fraction? An improper fraction is a fraction that represents more than one whole. Okay, so some examples of improper fractions might be something like this. Okay, so this fraction, we say it as 4/2. Okay, so the number on top in this fraction is bigger. So we call it an improper fraction. And it's saying that's more than a whole. A whole fraction, for this example, would be 2/2. Okay, that represents the whole because there's 2 parts total. But when we have a bigger number in the top, such as the 4, that's telling us that we have a whole and then some more. So it's a number that's bigger than one whole. Okay. We're going to go look at our target again. Today we're going to identify improper fractions, which I just taught you is any fraction that the number on top or in the numerator is bigger than the number in the denominator. Okay, so now we need to learn what to do with them, and we're going to turn them into mixed numbers. Okay, so let's take a look at what that looks like. Okay, so again, you're just watching and listening right now. So what do you do when you have an improper fraction? Okay, well, this problem says write 7/4 as a mixed number. So there's 3 different ways we can do this. So I'm going to show you all 3, and then you're going to pick whichever one you're most comfortable with, and you're going to use that strategy. Okay, so first we need to identify this as an improper fraction. And we know it's an improper fraction because the number on the top, 7, is bigger than the whole, which is 4. Okay, so we have an improper fraction. We need to turn that into a mixed number. A mixed number is a whole number and a fraction. So what we're going to do to turn this into a mixed number is first think about what this fraction represents. Okay, so it's saying our total number, and the piece that we're working with is fourths. So if we were to draw a tape diagram, what would 7/4 look like? Well, I know that each part is split into fourths, and I need 7 of them. So right now I have 1, 2, 3, 4 fourths, but I need 7 of them. So I need to draw another whole fraction strip. Okay, I'm going to split into fourths again because that's what this bottom number tells us to do. Each part has 4, or each whole has 4 parts. So we have 4 fourths right here. Now we have 5 fourths, 6 fourths, and 7 fourths. Okay, so now we need to look at this and think to ourselves, okay, well, I shaded in one whole tape diagram. So we're going to write the number 1 to represent that one whole. Okay, and then what's left over? On this tape diagram, we have 1, 2, 3 fourths left over. So we're going to write that as our fraction because it's not a whole number yet. So we turn this improper fraction into tape diagrams, and we found out that there's one whole and then 3 fourths left over. So our mixed number is 1 and 3 fourths. It has a whole number and a fraction. Okay, let's look at another way to solve this. So we know that the 4 is the total number of parts, and we know that we have 7 of those fourths. So this line can really stand for dividing. So this line means to divide. So if we're using our division, we're going to divide that bigger number by our total whole. So we're dividing 4 into 7. Well, how many times can 4 go into 7? Well, if we skip count by 4s, we have 4, 8. When we skip count once, we get 4. When we skip count 4 twice, we get 8. 8 is too big. So it can only go into 7 one time. Then we're going to multiply that 1 times 4 is 4. And we're going to subtract, like we learned in division, 7 minus 4 is 3. And there's no other numbers to bring down, so we have 3 left over. That remainder is 3. Well, that 3 represents the same thing that's up here. 3 left over out of 4. So our total mixed number is 1 whole and 3 fourths. Okay? So really, the last strategy is very similar to this one, where you just skip counting by the denominator until you get to the numerator. So if we write down our skip counting numbers, 4, 8, 12, 16. Okay, and we can skip count until we get to 7. 4, 8, oh, so we went over 7. So 4 can only go in there one time. So that's going to represent our whole. Okay, and then how many more does it take till we get to 7? 4, 5, 6, 7. And we're left with 1 and 3 fourths. Okay, so each time we're getting the same mixed number. Okay, let's look at another example. And this time you're going to do it with me. We're going to go back over all 3 strategies, and you're going to practice doing all of them and figure out which one is the way you want to use. So our problem says write 8/5 as a mixed number. Okay, well, what can we do with this 8/5? Sure, let's draw a tape diagram. So we're going to rewrite our fraction, and again, we have the little note symbol down here, so you should be taking notes and writing what I write. If you need to pause the video, go ahead and do that to catch up. So we know that this is an improper fraction, and we never want to leave fractions in this form. We want to turn them into mixed numbers. Okay, so what are we going to do? We're going to draw a tape diagram that represents fifths, and we need 8 of those fifths. So let's start by drawing our tape diagram and splitting it into 5 parts, because that's what the denominator is telling us. There's 5 parts in a whole. We need 8 of those. So let's start by shading in 1, 2, 3, 4, 5. Okay, so we have 5 fifths right now, but we need 8 fifths. So we need to draw another tape diagram, still split into fifths. That does not change. And then we're going to shade in the rest. So we have 5 fifths. We're going to shade in 6 fifths, 7 fifths, 8 fifths. Okay, so let's take a look at what we drew. We shaded in one whole tape diagram. So we're going to write 1 to represent our whole. And then we went to the second tape diagram, and we had to shade in 3 more out of that 5. So our mixed number is 1 and 3 fifths. Okay, let's look at our second strategy. We're going to divide. This fraction really says 8 divided by 5. So we're going to set up our division problem that shows we're dividing 8 by 5. So how many times can 5 go into 8? Well, if we skip count, 5, 10, 10 is too much, so it can only go in one time without going over. So we go to our multiplication. 1 times 5 is 5. We're going to subtract, and we get 3. So our remainder is 3, because there's nothing left to bring down. So our mixed number is 1 whole, and 3 fifths is what's left over. Okay. And then the last strategy, all we're going to do is skip count by 5s until we get to 8. Okay, and I noticed that we skipped over 8. So 5 can only go into 8 one time. That's our whole number. And to get from 5 to 8, we're just going to count up. So 5, 6, 7, 8. It took us 3 more tallies to get to 8. So our fraction is 1 and 3 fifths. So each strategy gave us the same mixed number, which is a whole and a new proper fraction. Okay, so we're going to go on to another example. This one's going to be a little bit different because we're going to have more than 1 whole. So our problem says write 7/3 as a mixed number. Okay. Oops. I'm going to choose to skip count because I think that's the easiest way. The tape diagrams are useful for a visual, but they take a little bit longer time to draw. So I'm just going to skip count by 3s until you get to 7. I'm going to divide the numerator by the denominator or draw a tape diagram. So I'm choosing to skip count until I get to 7. So I'm going to do 3, 6, 9. Okay, and I see that I've jumped over 7, but I know that 3 can go into 7 2 times. So that's going to be our whole. And then to get from 6 to 7, I only have to go 1 tally, 6, 7, and our denominator stays the same. Okay, and I end up with 2 1/3. Now it's your turn. I want you to pick a strategy and you're going to turn 7/2 into a mixed number. Pause the video now and go ahead and change that improper fraction to a mixed number. Okay, let's see how you did. You could have skip counted by 2's until you get to 7. So 2, 4, 6, 8. And I know that once I get to 8, I jump over 7. So I was able to get 3 whole counts before I had to stop. And then to get from 6 to 7, I'm only making 1 tally mark. And the denominator doesn't change, so you should have gotten 3 1/2. Alright, now it's your turn. Once again, you're going to change this improper fraction into a mixed number using any one of those strategies. Go ahead and pause the video and do that now. Alright, let's see what you got. I'm going to show you an example of my work, and you can compare it to yours and see if you got something similar. Okay, so here's my tape diagram I drew. I also skip counted, and then I also used the division process. Whichever strategy you use to find 2 1/4 is okay, as long as you got this answer. So let's review our target. I can identify an improper fraction and turn it into a mixed number. That's what you just did on the slide. We identified this as an improper fraction because the number on top is bigger than the number on the bottom. That's more than a whole. And then we turned it into a mixed number, which is a whole number and a fraction. Nice job. So today's summary. We need to change improper fractions into mixed numbers. We can divide the numerator, or the top number, by the denominator, or the bottom number. And we're writing the whole number followed by the fraction is what is left over. Okay, now it is time for your problem set. You have a Google Slides document that you need to click on, complete, and then submit. Have a great rest of your day.